to my channel. Today we're gonna work on the question Pascal's triangle 2. The question states, given an integer row index, return the row index 0 index row of the Pascal's triangle. In Pascal's triangle, each number is the sum of the two numbers directly above it as it's shown here in this animation. So for example, if we want the row index of 3, this is index 0, 1, 2, 3, so you want this row to be output, so it's 1, 3, 3, 1. And if you can see, so each row is the number above it added together. So this is number above is 1, 1, and then this one is 1, and then this one is 1 plus 1 equals 2, and this is 1. All the outer ones are 1, and then in the middle, like here, 3 comes from 1 plus 2 equals 3, and 1 plus 2 also 3 here. And for this one, 1 plus 3 equals 4, 3 plus 3 equals 6, and 1 plus 3 equals 4, and so on. So since we're on the recursion chapter, I'm going to try to solve this question using recursion. And for recursion, if you remember, there's always a base case, so let's determine our base case. And how do we determine our base case? Looking at this, if you see the base case should be if it's under like the index 0 or index 1, then we always return like the ones. There's no addition going, like it's just ones. So so if row index is smaller than 2, meaning if it's index 0 or index 1, then we just return 1 times the number of row index there are. But since row index is 0 index, so if we want to return the 0th index, we should just return 1, right? But this is 0, so we cannot have to plus 1. Yeah, and then if it's index 1, it would just return 1, 1, because it's 1 times 2. So this would be our base case, and the second property of a recursive function should be a recursive call. We have to determine a recursive call, and then the function of this sorry, excuse me. Base case is to terminate the function, the recursion, so it doesn't go into a loop. And then the recursive call is to reduce all cases down to our base case. So for our recursive call, we can have like a previous row equals this is going to be our recursion, so self.getRow row index minus 1. So this means that we keep whatever the row index is. Let's say the row index is like 4, we're going to keep reducing it. So 4, that's here, and then it turns into 3. 3 does not equal our base case and goes to 2. 2 does not equal our base case and goes to 1, and then it enters our base case here. So basically we're reducing our problem into our base case through this recursive call using previous rows. But to solve this question, the recursive call isn't enough, because we actually need to do the math here of adding it to determine each row. So after we this recursive call gets to the base case, we should do we can do a current row equals 1, and then we can add for I in range of previous, in range of length of previous row minus 1, because we don't want the outer layer. This 1 is for the left outer layer of 1, and then we're minusing 1 because this outer layer is also 1. We'll just add it at the end. And now we can do current row dot append previous row I plus previous row I plus 1. Sorry, my phone keeps beeping. It's from my company group chat. So now after this, it will all be added. Let's say, for example, I'm just going to turn my phone off. Let's say, for example, we're doing this row, so it's 1, 2, 1, right? And this is gonna be the length of the previous row is gonna be 2 minus 1, which is just gonna be 1, and you know, using the range is just gonna go to 0, so it's gonna be here the current row already has 1, so this left is already determined, and then we just append 0, and that's the one above, which is 0 plus 0 plus 1, which is these two. 1 plus 1 equals 2 to here, and then in the end we do current row append 1 again, so it becomes 1, 2, 1 for this row, and it keeps going, and we return the current row here, so that when we return this current row, the previous row for, let's say 0, 1, 2, 2, because this one, the base case only covers 0 and 1, and previous row is now at 2, and we build the 2 up, so we return the current row back to the previous row of 2, and now the previous row goes back to the earlier function that's calling it, which is 3, and then 3 will then go through this loop again, and then it returns here. Let's say what's passed in is 5, so then this 3 goes into this calling it, which is 4, and 4 goes through this again and returns, and then it goes to 5, and then it goes through the for loop, and then it finally returns the final answer. I don't know if that's a good explanation. So basically we're reducing this problem by using recursive callback. When it reaches the base case, it tries to build each previous row through this for loop that returns back to this previous row. Then it calls back to the previous function that's calling the previous row until we reach this row index from the beginning, and we solve this problem. So let's run the result. Let's try submitting it. And as you can see, it's submitted. And as for the time complexity, it's gonna be OK squared, where K is the number of rows, and space complexity, O of K, so because it has to store the answer for each row. Yeah, so this is my answer, and let me know if you have any questions, and thank you so much for watching.